Hi, today we're going to be talking about linear functions and slope. A linear function, as we've been talking about already, is a function of the form mx plus b. It has just two coefficients, an m and a b. And the m is what we call the slope, and the b is what we call the y-intercept. The m determines the steepness of the line, and the b determines where it crosses the y-axis. Now, there are a couple linear functions that we want to name. For instance, the constant function, or a horizontal line. This is a special function that has slope 0, and for this example here, y equals -2 horizontal line. It doesn't matter what x-coordinate you pick, -4, 0, 3, the y-coordinate is always -2. That's why we call it a constant function. It's constantly -2 no matter what the input is. Now, the identity function takes an input to itself. So, for instance, if you put in 0, you get 0 back. If you put in 1, you get 1 back. If you put in a 4, you get a 4 back. If you put in a -3, you get a -3 back. It identifies with the input. The output is the input. We call this the identity function. It has this nice 45-degree angle through the origin. Now, vertical lines, they're not functions, but we go ahead and throw them in there with the other linear functions to just round out this class. Now, vertical lines have undefined slope, as we'll see here in just a second. Now, slope is one of the two characteristics that determine a line. If you know the slope and you know the y-intercept, then you have the equation of the line. Now, the slope is unique for each line, and it can be computed with any 2 points along the line. The slope of this line can be determined by taking the change in the vertical between the 2 points and the change in the horizontal between these 2 points. Now, this is for any 2 points along this line. You get the same m, the same slope. Let me give you an example here. So here are 2 points. Now they determine a line. Any 2 points determine a line. So what is the slope of the line? Well, the slope of the line is the change in the y-coordinates, -1, -2. So it doesn't matter which one you call y1 or y2. So let's just use this second point as x2, y2, and this point over here is x1, y1. So the change in y-coordinates, -1, -2, and then the change in the x-coordinates, 2 minus -3. Careful with your negative signs. Now, two negatives here. So -1 and -2, that gives us a -3. 2 minus a -3, the two negatives make a positive, and so you get a +5. So the slope of this line that goes through these 2 points is -3/5. We often put the negative out front, but the negative could go up in the numerator, it could go down in the denominator, but there's just a single negative. It is a negative slope. All of these lines here, y equals x, y equals 2x, y equals 3x, all of these have a positive slope of 1, a positive slope of 2, a positive slope of 3. Now, if they're going down the other direction, these 3 lines all have negative slopes. So from left to right, it's important you go from left to right. From left to right, you are decreasing down the line. That's what we call a negative slope. This line has slope -1, line has slope -2, and line has slope -3. Of course, the horizontal line has slope of 0. It doesn't matter what the x-coordinates are. The change in the x-coordinates can be anything, but the change in the y-coordinates is 0. So there is no change in the y-coordinate. So we'd say it has slope 0. And then again, the vertical line has an undefined slope, because it doesn't matter what your y-coordinate is now. Your x-coordinate is always the same. X-coordinate is always x1, and then you have the change in your y-coordinates. So the change in the x-coordinate is 0, which gives us a division by 0. We don't like that, dividing by 0, so we would say the slope is undefined. Now, once you have the slope, there's one other thing that determines what your line looks like, and that is the y-intercept. So you need a slope, and you need a y-intercept. So you get this parallel lines thing here. So these 2 lines have the same slope, but different y-intercept. This one goes to the origin, this one goes through the y-axis at b. So y equals mx plus c. That's why we call it the slope-intercept form. All right, now this equation here is not in slope-intercept form. We've got 3x minus 6y equals 12. Now, in order to compute the slope and the y-intercept, we need to get it in the right format. So we got to get y by itself. So let's do that. Let's get y by itself. So we're going to take the 3x to the other side, negative 3x. We'll leave the 12 over there, positive 12. And then we're going to divide everything by minus 6. Now when you divide minus 6 into the minus 3, you get positive 1/2 x. The minus 6 into the 12 gives you a negative 2. So once you have it in this format where we've solved for y, you can immediately tell what the slope is. The slope of this line is 1/2, and the y-intercept is 0, minus 2. Once you have the slope and the y-intercept, you can graph this function. You can get a nice little picture going. So let me do that real quick. So we need some axes. So let's get some axes going. Now our y-intercept is 0, minus 2. So let's start there. 0, minus 2. There it is. So that is our y-intercept. Now we have a positive slope, so we know it's going to go from left to right, go up. And so so here we go. I can put the label down here, 0, minus 2. Now there's a couple ways to get the other point on the graph. You could use the rise over run. Remember, we could rise 1 and run 2. That's one little technique. So if starting at the y-intercept, if you go up 1 and go over 1, 2, you will land at another point on the line. And so then you can connect the two dots, straight line, and this is our line, y equals 1/2 x minus 2.